You want something that's kind of cool? I have two spheres that look on the surface identical and a copper track. Now, I'm going to release one of them and we'll see what we get is harmonic motion. That's what we call things that go back and forth. And it's getting less and less every time. And that's because it's losing energy. The initial kinetic energy is losing to a little bit of heat and friction and a little bit of sound that you can hear. Kind of interesting. Now I'm going to take this other sphere and let's see what happens. That stopped almost immediately. Why is that? Is it high friction? No, they're the same friction. Well, it turns out that one of these spheres is very magnetic. Very magnetic. And the other one is not. Now, they're both not attracted to the track. And that's because the track is made out of copper, which is not ferromagnetic. So it doesn't attract the magnet. However, copper is a conductor. And it turns out that conductors resist change in magnetic field. So this is a magnet. So as the magnet is moving along, there was no magnetic field present, and suddenly one becomes present. So to fight that change, it wants to make an opposite magnetic field. So it produces eddy currents, we call them, little currents in the metal, to make that magnetic field, because currents can make magnets. And that stops it very quickly, because the eddy currents that are being developed here are losing energy through heat in the metal much faster than the friction does. Now, this idea that conductors resist change in magnetic field and produce current is how regenerative braking in electric cars works. It's how lots of different things in the modern world works. It's actually how we produce electricity point blank in all of our generating power stations. Physics is pretty fun.